Hey peeps, an important physical law regarding linear momentum is known as the law of conservation of linear momentum. What does it mean? What does it say? Well, we've seen the conservation of energy before, and so it's kind of a similar concept, except its applications are slightly different. Let me explain. The total linear momentum of an isolated system is always conserved. Always, always, always. What does it mean to be isolated? Well, in terms of objects, it means that no external forces act on the system. It doesn't mean that isolated, like I am in this room, it's nothing like that. It's just that these forces are not present. It's only internal forces that are involved. Okay, so it's a simplification in some regards, or we can neglect a lot of the other forces that aren't significant. And so what we have only are internal forces. So here's an example where two of these balls collided, like a billiards balls, for example, a pool table, the blue and the red, or maybe they're Christmas ornaments or something. And what we have here is ball 1 exerting a force on ball 2 due to the collision. And because Newton's third law, this is closely related to Newton's third law of motion, it has to be the reaction force as well. So we have F12, the force of object 1 acting on object 2, and the force of object 2 acting on object 1. They're a pair, forces come in pairs. These are internal forces. They're interacting with each other. We have no external forces on the system. There's no other push from there. Okay, so that's the situation in which momentum is conserved, and it's always conserved. Unlike energy, which in terms of mechanical energy, some of that energy is dissipated into the environment through friction, as heat, as sound, as vibrations. So mechanical energy isn't always conserved, although total energy is if we take the environment into account. But if we look at the system, that system loses energy, but it won't lose momentum. The total system conserves momentum such that for two interacting objects with mass m1 and m2, p naught equals p final. Remember that p is momentum, sign of p. And this is the overall expression for these two objects. We have m1 v1 naught plus m2 v2 naught equals m1 v1 final plus m2 v2 final. This will be useful in analyzing collisions, which we will do two types soonly. Morad out. Oh.